Ha, it's working. I had to replug it. Wonderful. So we can now disable studio mode and I can set up my screen. Wonderful. I could have tried that a few minutes ago, but I didn't know about that failure mode. Wop wop. So maybe a good start today is clarifying a few things. Namely, I could have a better color scheme for the chat. Sorry. Maybe clarifying a few things. So this thing that I pointed out about reverting this one commit, that had nothing to do with my issue. Also, there's not big discrepancy between licks and nix. It's just that the JSON output of the show derivation command is not stable. Yeah, I don't know if Nix considers it stable. It's an experimental feature, I guess, so probably not. It's just like a bit of a discrepancy and my fault for relying on it. There's various ways we could get out of that issue. I just wanted to clarify that so that it doesn't look like I'm blaming other people for the things that I'm doing wrong. Yeah. Aside from that, like yesterday, what we managed to do is do some verification, or at least do the dependency resolution for quite a complex derivation. And it's complex because if we can verify this, it means we can get through the whole bootstrap, which is great. And we can build on that. So there's a couple of things that I'd like to do today. Maybe let's start out with the contribution that has been sitting here, because we want to like cooperate with people, right? And Serge took the time to sit down with me and do this. So instead of having it sit here open, I think we can take some time to see what he did and apply that, because there's white space changes in there, and so I think it probably makes more sense to manually redo some of these things, because it will probably be difficult to merge some of them. I mean, this doesn't look that bad. Yeah, here we have a bunch of reformatting. And this is not really relevant anymore. This, like, we were investigating an issue, and since I have a way now to get a completely content addressed thing, I don't really need to worry about what exactly did I do wrong earlier. I mean, if somebody wants to spend the time, be my guest, but we don't have to concern ourselves with this. So maybe I'll just start here at the bottom, because we're gonna just identify what we want to take. This okay, Nix instantiates that derivation, which is useful. Maybe, but I don't like if I want to reach for that, I can reach for it here. I don't understand this well enough that I can integrate it right now and test it and all of that. This is just a white space difference. This is also just a white space difference. Okay, here we're doing Nix instantiate. Okay, so this is using Nix instantiate while we're using Nix space build -f. And then like the attribute of the package attribute. Yeah, maybe it would be better to use Nix instantiate, but this is not the first thing that I'd pull out of this right now, because I don't think there's a big distinction. I'm not familiar enough with the Nix instantiate command to tell actually. Yeah, okay, we just have we can have like a Nix packages reference in those brackets here. I don't remember what this kind of parentheses is called in English. But I get that we can use the repo without flakes if we make those changes. Or that's part of the point, which I think is good. What happened to this? Okay, this is here. Is there something different about it? I don't think so. Nix git laut extra config. Yeah, there's not really a difference here. But we have the make test stuff here. Name extra config trust model. Okay, this reference is renamed. NixOS test dot notes. Okay, this is up here. Spam verify. Yeah, there's not really a distinction here. Okay, this is renamed. And like this clarifies that the content addressed one has a separate name. So this also introduces a different name for the input addressed packages reference, which you can do. What happened to this registry? Okay, this is using Nix path. Like I found a way to deal with this issue basically of, oh, how can I get a Nix packages version into the test that is consistent with what we have outside, and like me relying on Nix path for that is not a good idea, because I don't use Nix path for anything ever. So I'm just gonna stumble into things that I don't understand. So basically what we're doing here is making sure we extract all of, like we get the valuable pieces of this. This is something we can do. But we'll also have to keep the other package around. And we don't need to do this. And that's the scope stuff here. Okay. Do we ever use that scope in that file? Okay, we just take laut from it. Yeah, we can do that. And then we have pinned versions of Nix packages. Are those the same that we have in the flake, is my question. I mean, this look like probably not anymore, but this scope stuff helps with, like, as far as I saw, splitting up things across files. So that makes sense. And being able to pass a different version of laut to this file also might make sense. Yeah. But if I introduce this, then this means that these things can run out of sync with the flake. And here the setting the flag works, apparently. Like, we didn't actually get to test this. So maybe, like, because we were looking at what's wrong with my content addressed instance of Nix packages, and we were able to construct one where things properly work, and use this to look at the differences on the with, like, Nix instantiate, like what exactly is different about the one that I generate with the errors in it. Okay, so this has a verify fail file, a laut file, and moves all of that stuff out here. That does make sense. And then we have a default.nix file, which is where I'm saying, okay, I know that I could use something like npins in order to manage these dependencies, but I want to do that stuff in a way where it's by definition somehow consistent. I probably have to look into that. Oh, this override is nice. That replaces a bunch of stuff that I do in a much more stupid way. Yeah, let's do this. Let's do this. We'll pull out the... Yeah, laut is the package that we're trying to build. Yeah, so should we call this... Or I think there's a Nix folder and it has laut.nix and Nix verify souffle.nix. That makes sense. So definitely this is untested because there's no package.nix here, right? But this makes scope stuff sounds interesting. How do we reference this in, like, scope.loud? Where do we get scope from in here? Scope is packages call package. Oh, and then we're calling the default.nix and we're passing null as Nix packages. Okay, that's how it's consistent. But then we're just not using the Nix packages input of the flake. So I'd have to remove Nix packages from the Flake inputs, I guess. I mean, that makes it consistent. Yeah, this is something that I want to do. I want to do this, definitely. Make the Flake file smaller, have a Nix folder in here, and have the individual things be like Nix packages style packages that you call with, that are invoked with call package, right? Is the name of the function. I think that makes sense. The default Nix thing, I need to think about this, but I see that it's consistent if we get rid of the Nix packages input on the Flake level. So that's good. But I'll probably, like, this is not the kind of thing that I can handle on stream right now. I just can't manage to do that in terms of brain and the required attention to detail and the iterations to go through that. So thank you very much again for helping me with this. Maybe we can talk about the Nix instantiate aspects of it again, and you can explain to me whether or not I still benefit from that with where we are at now. Yeah, thank you very much, Serge. This is great. Yeah. One thing checked off the list. I actually wanted to really, like, my plan originally with the stream was, okay, let's take the things from this and do it on stream and merge it. But I feel like this is too much for me to do in terms of time management, because we have the goal for this week of hey, let's get the hello thing verified, and I probably need I need a lot of time in the stream today for this, because I need to learn about stuff, right? And yeah, we can learn about this together, and it's fun to do that on stream, but it's like not the theme for this week. So I want to stay on track a bit. All right. Then let's continue on topic. Oh, generic bear, what's up? Anyway, congrats. Thank you. That's very nice. Yeah, managed to get through the week, I guess, right? That is good. So yesterday we were able to do the dependency resolution for the hello binary, which is good. And how I wanna kind of conclude this week, since our goal is to get that working. The way I wanna conclude is trying to work towards making this accessible outside of a unit test. So taking updating the VM tests to do this, making it so that the actually resolved thing is compared against some local reference. Those are things that make sense. So trying to work on the end-to-end user experience. In the end, we're still probably not going to be able to advertise the outcome of this week's work to users directly, because we depend on the JSON representation of derivations, and so people using different Nix versions will just have a bad time, and I don't want to do this to them. So we will have to fix that issue before we can say, hey, try this out yourself. There are a few ways we can go with this, and they are all like possibilities. One of them is just taking what we get in the build hook and normalizing one thing into the other. And this is kind of starting a game of whack-a-mole, because we're taking something that's apparently not stable and trying to make it stable, but we might win that game of whack-a-mole. I'm just not sure. We could also rely on some third-party thing which computes computes a JSON representation of the derivation for us, or just computes like the output hashes for us, and then use that, patch that into our JSON representation. We could define some other, we could just switch the signing to be compatible with Nix. This is probably the most straightforward thing to do, funnily enough. But then, one thing that's bad about the A-term representation of the derivation is, can we maybe show this? Let's see. I actually don't know. Nix derivation show. This is the hello derivation. Can we show like the A-term representation of this? Okay, I did some really intense work and logged into Claude here before the stream. And I'm gonna use that hard work in order to ask, how can I print the A-term I mean, probably I just cat the DRV file, right? So we just look at the path here. Yeah, this is our A-term representation. I mean, it has some descriptive names in here, so it's not the worst thing in the world, I guess. Because just from a philosophical point of view, this just looks to me like I had the impression that this is just a soup of values, but it's not absolutely horrible. Like, a lot of people have negative things to say about it, I think, because usually people don't have to deal with A-term, and I don't know how good or bad of a format it is. Like, the impression that I get is that it's not great. But if we switch to this instead of the JSON representation, then we're fine. Or if we ourselves derive a JSON representation from that, then we're fine. Or like this hash is actually a hash of this. And what we can do is we can do that same computation, and then we'll have like compatible hashes, and we'll just use absolutely the same, exactly the same hashes that Nix does, which would be really good. But then we can only do that right now, because for the plans that we have for input address derivations, we're gonna have to add something to this hashed representation anyways. And then I don't think we're gonna add something to the A-term representation. I'm not sure. but I don't think so. So we're gonna have, as soon as we, like for input address derivations, we're gonna have different hashes for sure. But for content address derivations, we could have the same ones. And then there's also like the goal of, if we want to do content addressing and we're defining an independent signature format, that independent in the sense of we can pick what the primitives are that we use. We can pick the hash that we use. We can pick the input hash. We can pick the content hash. We also can have multiple options for that. Then why bet on a term if people are complaining about it? Why not try to find like a better basis? So if somebody has something, I'd be really curious about that, because I'm looking. What the SNIX people use is called like a build request, but they want to turn that into a streaming protocol. Oh, we have a Rust person listening. That's good. So let's teach them. Let's tell them about SNIX. SNIX is it used to be like the Twix was a Rust implementation of Nix, and SNIX is a fork of that, and realistically speaking, the actively developed one. It was forked at Ocean Sprint, where like the fork was enacted at Ocean Sprint, where I also was. I know some of the people working on it, and it seems like a really a great effort that has made great progress. Has a bunch of really interesting components and is very ambitious in its design, but they've been like for years working on this consistently and making progress, which is great. Yeah, a lot going on also on their issue tracker. So they have a format basically that I don't know if their format has some canonical representation. If that has a canonical representation, then, you can take their build request format. If it has a canonical representation, you can take a hash of that. And you could basically resolve a derivation to a build request and use that as the input hash. They also have like a very interesting content, they have a very interesting content address store, which has a defined hashing scheme, which is an interesting alternative to NAR, because NAR also has some flaws, the NAR hashes. And like this also ties in with the plans that I have for input address derivations, where I want to kind of find a good way to go to actually create realization that not only work for content address derivations, but for input address derivations as well. And I feel like this. I'm listening. Great. So to about the Rust stuff, right? So they have this content content hash as part of their content address storage layer, or this content hashing scheme, and that might be a good replacement for NAR hashes. And how that ties into my plans with input address derivations. So ideally, what I'd want to do is, I can look at the issue. Yeah, just like we want to add another field to the resolved derivation that gives you all of the information that you need in order to that gives you all of the information that is also in the that is in the realized that is in the input hash of a resolved derivation, and in the content hash of the output of a resolved derivation, if all of its dependencies are assuming all of its dependencies are content addressed, so in a purely content addressed world. Because on the content hash side, which is the equivalent of the nar hash, there's like this Merkle tree property where all of the references that are in that hash are also content addresses. So you have the precise identity of the thing itself and all of its runtime dependencies reflected in that hash. You don't have that for input address derivations. But so you would have to have some way to also represent this information to make the output side of that equation like equally precise. And on the input side, it's similar because you don't have the precise identity of all of the inputs of an input address derivation. Well, for the content addressed one, you do. And you would also have, again, to find some way to also include that information not in the input data for this input hash, which is the breaking change or addition that we would have to make in comparison to the A-term based format that Nix uses for to represent derivations. So we would have to introduce some extra data here, or like use a different format in order to get that data in. And now, like, something that's not reflected in this issue yet, but which is still the case, is and let's frame it as a Gedankenexperiment. That's as a what if, because I think that's the easiest way to frame it. What if the realizations of an input address derivation, first of all, we want them to make, like, let's call them traces. What if the traces of an input address derivation exist? So we make that a thing, and it has all of the same information that the content addressed ones do. And then the kicker is, what if we make them actually exactly the same? So the input hash of an input address derivation and the content address derivation, the resolved input hash, if the only difference is that one is configured to be content addressed and all of its dependencies are content addressed, and one is configured to be input addressed and some of its inputs are input addressed, like, this representation will still be exactly the same. And the distinction between the two moves into the builder section of the signature. So in the builder section of the signature, we say, oh yeah, this was built as an input addressed thing, or this was built as a content addressed thing. So for the content addressed case, we know, okay, this is the simple good case where we probably can uphold all of those guarantees that we're making way easier, and the input addressed case is just the compatibility case and we're trying our best case and the migration path case, basically. So those hashes would be the same, and like on the output side, you can do the same thing. You can say, well, let's create a hash of the output, but it's not a verbatim hash of the input addressed output. It says, let's pretend that this is content addressed and all of its dependencies are content addressed. So while we're hashing it, let's make it look that way, so we get exactly the same hash. And one of the reasons why I'd like to pursue this direction is, if we do that, it gives us a migration path from content address, like from input address derivations to content address derivations. Because in the post build hooks of Hydra, for example, we can add this signature scheme to the post build hook, and by that we will start like collecting data about how well content addressing actually works, about how much of these, like, we can from that paper from that data probably tell how much we get out of the early cutoff optimization, for example. We can tell could we actually have purely content addressed clients like fed from this data and things would work out. We can have trial runs like that, and I think that creates a better migration path to content addressed derivations, because if you don't have things in the cache, it's rough to switch to content addressed derivations. And so you don't, and so you're stuck on the input addressed ones. And this way we can like try out the logic and the machinery, add it somewhere. We don't even have to push it to the official cache, right? We can push it to some other domain, some other URL, some other service where we just have a database running that collects these signatures. And like we don't have to, like this doesn't have to be stable right away as well, because that's how the signature format is designed. It's designed to evolve, and the worst thing that happens if you have a mismatch is you have a mismatch and it doesn't verify, right? Still, we don't have to push that data to the cache. We can push it someplace else, but we do have like it gives us a migration path there, and this is not so far off because we can see that because there is a feature in Nix where you can actually rewrite store contents from input address to content addressed. So doing this as an operation on the client side already works and kind of proves the principle. But like the theoretical basis of this is, well, we can just, however you do that hashing, as long as it has all of the relevant information in there, all of these representations of the same thing are kind of equivalent or isomorphic or whatever you want to say. And so we should pick the thing that helps us get to where we want to go. And this is kind of like big picture, something I want to get to, but not right now. I just enjoyed the opportunity to talk about it. Yeah. Other things I want to get to next week. Maybe I'll talk about those at the end of the stream. Let's try to improve let's try to get coding now. Try to improve the user experience. So theoretically we have a we have a unit test that works now, or a set of unit tests even. And there's some improvements we can make. Let's see. What do we do? How do we start this effort out? Let's look at the CLI right now and check what's missing so that we can do actual verification. Or no, let's go to the, let's do that. So we have a verify function, takes the target. Right now it doesn't take, like it takes a hash and it takes hashes and trusted keys, but it doesn't do anything with them. I think this is something we can change. So we have those, let's assume we have those caches and keys that we take in. We can add them to the config actually. And Then we also look at the reference we get in, and theoretically, like this doesn't verify, like this verifies, like what we do here is we resolve the dependencies, but we don't verify against any like existing thing. So in order to start doing that, either we can implicitly assume that what we're verifying is what's at the result link right now, or we have to explicitly set a parameter. And like I've been thinking that for consistency reasons, something like this could be nice, because this is consistent with the Nix CLI. Like outlink can be something different, but if you don't specify it, then we take result. And we have the cache parameter, we have the trusted key parameter. We're just not using them right now. Yeah, let's add this to the config, I guess. Because we're already setting things here. This makes sense. The lifetime of this program is not going to be more than one operation. And like passing these things around is a bit annoying, so I think it makes sense to put this stuff here. Self caches equals something, self keys, trusted keys equals something. And we're also gonna get some, should we put this to none? Yeah, makes sense. Caches, we have a default in here which isn't working, I think, because it's just commented out. Will we ever be able to use this? Let's set it to none for now. Then we'll go back to the CLI. Okay, this is debug, we don't need that, we just need the verify command. And we're already reading those keys. Oh, it's a dictionary, okay. Trusted keys equals trusted keys. Now it's complaining. Okay. I'm not a Python programmer. I just happen to be writing Python, but Python's flavor of typing is just really annoying, because yeah, I could fix this now, but why would I? I don't know. Then we need we got the keys. What about caches? We're not doing anything with those. I mean, we could just take in what we get. Like it's gonna be multiple. It's probably gonna be a list of strings, right? Let's go cache. All right. I mean, that should work. If this is correct, we could also just add it as type information, I think. I'm really open to rewriting all of this in Rust. I just wanna. I don't want to do the work, but conceptually, I'm very on board with this idea. Because I can be a terrible Python programmer. I can be a terrible Rust programmer, but at least with Rust, there's hope somehow. Because I don't think, like, I don't want to be a great Python developer. Yeah. What we're trying to verify, we pass in as a parameter here. So basically we are done. So let's see if we go into this. We first build the unresolved tree and then we do verification. And here, like, we can fix some of the. What we're doing now is trying to make this thing work end to end, right? So we're doing some implementation work on it. We can just get rid of that parameter because we get that through the config now. And we should also, yeah, this can be called verify tree, I guess. And we don't need to pass in this trust model parameter. Like, in the future, it's not going to be a set of keys. Oh, hello, Dawn. Nice to have you here. I have I have a really amazing setup here. I can do all sorts of stuff. I have oh no, I don't want to show that. I have green screen, I have lighting. I built this for the pandemic at my university. Not just me, but other people were involved as well. But yeah, I was the guy who said, "Oh, let's use OBS and pretend we're streamers." But then I didn't use it much during the pandemic. Okay, so we have this verify tree function. What do we actually want to return from it in order to make this thing work end to end? Like, right now we're returning a list of trustlessly resolved derivations. What is this dictionary again? I don't recall what's in here. Maybe this is good, I don't know. We can just look at this with the debugger, right? Just go somewhere here. And also hope that our intermediary changes here haven't broken anything on the way. Oh, unexpected parameter. Yeah, that makes sense. How will we pass that in the future? Yeah, let's not worry about that now. So we're gonna return this root result thing, and this has one trustlessly resolved derivation, which is good. I think if resolution didn't work out, this would be empty. So is this a list or what is it? What's the type of this thing? Yeah, it's a list of trustlessly resolved derivations. It actually comes back here. And here we're returning, this looks like a set. I think in other places I have capitulated, because if you want to return sets, you have to make things hashable. Here we're returning plausible resolutions. Plausible resolutions is, I think, a list. Yes. So the correct thing to do here is probably also doing the same thing. And we just ourselves have to take care of not adding duplicates to this. Why is my keyboard behaving strangely? Or maybe I just forgot how parentheses work. Okay, so this should be better. This was not closed. Did I? Oh, I ruined it. Now this is happy. Yeah. I see that there's still an issue there, but what we're getting back here is a list of trustlessly resolved derivations. If this list is empty, then verification failed. So we can go down here, call this matching this is a list of successfully resolved things. If this list is empty, like we can print something here to the user actually. So we have a return value from our so our command line command actually tells us something, right? We have some similar message in the log already, but we will see. You see how I'm saying this is trying to make things more user-facing, trying to get like a better end-to-end thing. Print fail to resolve. But I think this is not unit tested, right? Interesting. What should the return value of this be? We should probably like success and failure, things like that, right? yeah, I mean, this is a bit more explicit than we would have to be, but return true and false here. And then in the CLI we can reflect this in the exit code. Oh, we already do. Good. Okay, we're using click here for that. Is that better? Maybe yes. So let's get rid of this and really just return the successfully resolved stuff. And then we will see we have all of this data now, right? So we can say we successfully resolved some derivation. Actually, we can take really the thing that we started out with and then say what did we start out with? Because if we get a flake reference, we resolve it, right? We just call this target. Successfully resolve target to the thing that we successfully resolved it to. And then we don't need this, I think. Where's this? I'm just creating a bit of a mess. If successfully resolved, then we say this. And else we say failed to resolve target. Good. This is an error. I think this makes sense. We should have a different exit code if there's something that goes wrong. Maybe we should really have a very distinct one for this case. Okay, looking good. So if you're here curious and watching the stream, maybe I can also interest you in, like, there's a matrix channel, and there's not a lot of people in there yet, but I want to like update people there what's going on and use it as a jump off point to do interesting things, talk about a few things, right? I'm not monitoring it right now, but as I'm saying that, let's take a look. Yeah, if you want to, feel free to join. Just wanted to point that out, that this exists. Okay. So we have like the output side of this done, but we're not taking in any data yet. So maybe we could check how does verification work how does the signature fetching work right now? Because in the unit test where we made things work, we're actually feeding the verification logic from these JSON files that we have in the test directory, which is of course a bit easier because there's no network communication involved. And for a long time, I've only used the VM tests as a data generator for these unit tests in Python and some integration tests in Python. And we can now start changing that again, but we gotta kind of pat down all of the bits that might have eroded a bit. So, are we using this? Oh yeah, this. Okay, so this is already like trust model related and all of the trust model stuff. I'm not gonna do this in Python anymore. It's gonna be in a data log program that's already in here, which we're not running yet. But the input to the data log program is just gonna be valid signatures that fit our criteria in terms of which keys are they for and which extra criteria do we have on those keys. And then the data log program is going to do think about like the grouping of keys, because I have a scheme figured out for that, how we're gonna make policies that are more complex, that involve sets of keys and the ability to nest those sets of keys and have criteria like, well, in a set I want 3 out of 5 to agree or something. And like one of the participants in the set can not only be a key, but can be like another set with similar criteria. So you can nest those. And I think you can express pretty much what you want in terms of verification that way. But I think Datalog is the right place to do that. And that's also not implemented yet. But for now, for just getting something usable, the in-between thing I want to do is either not care about signatures at all, or just have the ability to pass in a set of keys and actually do the verification, but you can just have like a big OR. So all of the keys that are passed in, they are all equally trusted, and we're not aggregating information yet. We can't say, well, 2 keys have to agree, so there's no ends. Because the ends are implemented in Datalog, basically. And I think that would be reasonably easy to retrofit. So I'm thinking about that now. Doing all of this in Python, like the aggregation stuff, doing that in Python would just be a mistake, because I really, this trust model code that I started writing, I really didn't like it. The issue with doing that in Python was I already have like lukewarm feelings about the recursion in here when it comes to like the verification logic. We recursively go through the trees of through the dependency tree twice. One time for actually building up a typed tree in terms of Python types, and then the second time in order to collect all of the signatures from various places and eventually in the end invoke the datalog program. But so we do the datalog program afterwards. We don't do it in a recursion. But like, this is working like semi-well. The typed representation of this data, I don't know if we benefit from it. Maybe it will go away. So that first recursion might go away, and kind of if this trust model logic creates another layer of recursion. So you want to recurse in one direction, you want to recurse in the other direction, and you have to, in your program logic, express that, and you have to decide which one is going to be the inner one, which is going to be the outer one, and maybe there's good patterns for that, but I don't know them. It's just a big mess. It's not very fun, and so we're saying, well, I think the sensible thing is to get rid of the trust model related verification and do that in a logical programming approach. Yeah. So we have a verify signatures function is what we saw, and we have a place where that should be called, which I also think I know, and that is down here. Like, this is the second recursion that I talked about, where let's rename this. Let's rename this collect signatures. So this looks good. So I want to really try to also make the code base more understandable and cleaner over time. Because, yeah, it should be understandable to people. Like, this project has a lot of bits and pieces that people could work on independently in theory, because it's not a lot of code, but it's like a lot of different things that are involved. It's pulling a lot of things together. And so I'm eager to accept help. All right. So we renamed this now. We will see this will blow up in so many ways. But let's get back to this freshly renamed function, collect valid signatures. Right now it's lying because we're not verifying, right? So here we fetch the signatures. And then here we are kind of, I think, pretending that they are valid, which is something we can fix. Because, yeah, we're fetching them. Should probably not be in the fetch signatures method, actually. We should probably filter those down now to the valid ones. Yeah, maybe let's create a different method in here. Fetch and validate signatures. And first we're gonna fetch them, and then we're gonna validate them. So we're gonna get back a smaller list. So the no-op version of this would be this, but that's terrible, right? And then we're going to return those. And here we need the same input, like some input hash. And then we pass this in here. We get all of them back and we filter them down to only the valid ones, and then we return those. And this is what we should actually call in here. So here we're computing all of the possible, all the hashes for all of the possible resolutions, and further down we do the signature fetching, fetch and validate signatures. We're gonna import this. And this CT signatures term is something that we can also eliminate. Because it stands for constructive trace, and I think it's confusing for people. But I'm not sure if I remember the term I wanted to use. Did I want to say resolved signatures? We can call them trace signatures. Because we call that data like build traces or traces. And it's a specific kind of trace, and yeah, should we say resolved? Yeah, but we don't want to use the term. Do we want to use the term unresolved trace for the signatures that Nix generates now? Yeah, maybe. This is better than the status quo. Good. So we're invoking this function now. This looks actually like quite a clean change. Now we still have to do the verification, right? We need the keys, and we need a list of signatures. Why do we do this with a list? I don't know, and it's only used by that unused trust model code, so let's change it. Let's just have a signature in here. Is there a bunch of work that we have to do for each signature? I mean, yeah, but let's not worry about that. Oh, because we want to have statistics. Yeah, we can put those in that other place. I don't think there's any other top level logging statements. So this can go here. Should we call that verify? Let's not get lost here. Verify trace signature. Yeah. Fetch and verify signatures. Collect valid signatures. Fetch and validate. Okay, the import is wrong now again. We should rename this again. Because we're recursing through this tree. And otherwise, like, we have too many things that are just about, oh, let's validate this, let's verify this, verify that. Good. Rename symbol, let's try this. Verify. Resolve trace signature. Did this work? No. Oh man, what is wrong with people? That quick fix button is just like not cooperating. Okay, just verifying each of those. I think what we get back is actually unwrapped then, right? Because we get rid of the headers and all of that stuff, and we just have the parsed JSON payloads. Yeah, we have to need to keys a signature, and we need a key, a signature, and an input hash. can get the keys from the config. We also have to recurse on the keys. To pass the key here, and we get this dictionary back. This is the JSON we get back. We're gonna have to move things around here probably, but I'll try to, like, if I do something like this where I change a bunch of stuff and try to run through the code, I renamed some things, but I'm not going to start moving things around because we're going to have like chaos erupting. So we'll have to create a bit of a mess now and try to solve the technical challenges, and then we will clean up. Verify resolve trace signature. Yeah, it returns this thing. And then we just append this, right? Okay, that's that. I don't know if a length of a dictionary is the correct thing here, but we will see. Now let's also check when it comes to fetching, what do we actually do? Nothing, right? Or what do we do? Yeah, I think I commented this out because if you have this in, then like the network latency just makes the runtime longer. And this was just the URL that was in there for demonstration purposes. Because the trace signatures, you don't have that in cache.nixos.org, right? If we ever use, like there's another, in addition to supporting input addressing, there's also the question of supporting those signatures. So theoretically we can, in the language that we use to describe the trust model that the user has, where he says, well, I'm trusting this signature with that key and this signature with that key, or like aggregations and so on. We can also support different kinds of signatures with different semantics. And I actually kind of want to have the current signature scheme that Nix uses in there, but the point being, if you use that current scheme, you just have a lot worse security properties. And if we find if you configure it to trust a signature like that, it doesn't look at the whole tree anymore. It stops there and just doesn't recurse further inward. At least in principle. In practice, we're probably still going to be continue because Datalog is going to make that determination later on, which is fine for now. But like from a purely conceptual perspective, since the current signing scheme just ties together the leaves in the dependency tree and the final output, it doesn't, like all of the verification we could do further in the tree is just conceptually pointless because those things are not actually related by the signatures we're looking at, or at least that one signature that we're trusting in that one step would kind of break the chain anyways. So let's not look at the upstream parts of that broken chain. And I think this is also like just a communication, a question of communication. If I do it like this, I can clearly communicate to the reader of the code or the reader of the paper, hey, like this is the distinction. If you use this kind of signature, there's no point in going through the tree, because those things are not really tied together. And so we might as well just stop here. And I think that gets the point across of what the distinction is. So it's like partially a communication tool. Oh, so the cache URL, we can integrate that with what we have in the config now. Cache URLs, let's call it that. Let's just also make it empty. And we'll just say config.cache URLs. They should be fine, and we'll just remove this here. Yeah. I mean, I get that this is a type error, and we could probably gate that away somehow, but I'm not going to do that right now. Also don't know if the key format is correct, but like we're getting in the direction of this being something that you can actually invoke at least. Like I'm assuming this is an empty list if we don't pass the parameter. So this should be fine. Let me look at the signing operation, because I have another exit code in there. Yeah, 117, 118. I think that's nice to have those next to each other. Okay. Let's see if we can actually build this. Oh. Okay, we have a bunch of tests failing. Verify trace signatures. Imports. We gotta fix imports. What else do we have in here? Oh, it's actually this twice at least. Yeah. This red. What did we call this? Verify resolve trace signature. Rust model. It's a bit unfortunate that this even we should maybe throw this away. Let's see. Okay, assertion errors. Has no... Man, I want to know how that message ends, so I'm just going to rerun it and get some water. One failed thing. And 2 errors. Okay, so one actually failed test and 2 errors. Attribute model object at has no attributes, fetch CT signatures. All right. I know my workflow is kind of not great. Oh, sure, because the tests. Fetch resolve trace signatures. Cool. Like I really enjoy just having a type safe language. Has no attribute. Verification, fetch signatures, fetch resolve trace signatures. Is it that? This is strange because I don't. Don writes he loves teaching or learning Rust. Teaching. Yeah. Yeah, maybe you can teach me some Rust. I do know conceptually a bit about Rust and the borrow checker, but I don't have any practical experience for a long time. I followed the Rust project like a long time ago, but at the time I found it too complicated, or just didn't stick for me. But this was really a long time ago, and I haven't taken a serious look since. So yeah, I mean, maybe I'll send you a Rust question if I actually start rewriting this in Rust. I was kind of hoping that somebody would say, "Oh yeah, I want to do it," and probably, like, realistically speaking, I'm not sure if I can afford the time, because I feel like, yes, at some point it's gonna pay off, because I run into a lot of issues with the looseness of Python, but I will also run into some issues with the strictness of Rust, and it's kind of a trade-off. And one thing that I have to do is I have to like be efficient in trying to reach my goals, because I wanna like get things done this year. Go places this year. So it would have to be like a very smooth Rust rewrite, I think. Okay, what is happening now? We actually only have failures now, which is good. Verify, like wrong arguments to verify tree. This is fine. Like, it's not fine, but we can deal with that. Yeah, we're just not passing this trust model thing here anymore. We will do this differently. We will have to set the config here. Like, put this in via a mock that mocks that part of the config, which I think is fine. You support reaching goals. That's great. Yeah, thank you. Like, I don't know if you mean like in general, or with this effort specifically, but yeah, I really I'm taking this seriously, which is one of the reasons why I'm streaming it, because I want to communicate that I'm taking this seriously, and hey, people can watch me mess around with the stuff. Okay, build unresolved tree, verify tree. Yeah, we removed this here. To do, pass this in via mock. So I'm actually quite happy with this, because it seems like annoying. It seems a bit annoying to have to update the tests, but to me, the more of these things that I can fix on the unit test level, the less I have to like interpret things on the command line, and like, if I can fix it in a unit test, I want to fix it in a unit test. If I can't, then I go to the command line, try running it myself, and then if I can't do that easily, then I want to go to the VM tests as kind of the big gun that does really the big integration across systems. But if I can, like, the smaller the scope of the thing I can have in my iteration loop, the better. Yeah, fine. What is the non-object? Probably we're gonna hit this issue with both of those tests now. No. File exists error. Interesting. I'm thinking now. Let's search for this, because from this context here I can't really tell. So we're trying to create the we're really creating a temporary directory, and in that directory that's specific to the unresolved derivation. And I'm wondering, how is it possible that this existed already? Because I don't think that I changed anything related to that. So maybe we will have to just put a debugger in there at that point. And this was with the large test, I think, right? Let's go down here. Yeah, the large one. So we're gonna try to take a look at that. Oh, was it? Could it be because this thing was running? No, I don't think so. Like, we should have a really completely different directory every time. We're hitting something different here. But why? Because we're supposed to run the other test. Well, but this is one of the issues we had anyway, so let's see. Non-type object is not iterable. Trusted keys, it's actually none if we don't pass a parameter, apparently. Or no, it's none because that's the default thing in the config. So either we have to properly mock this now, or we have to just, like, the cheap thing to do, which isn't too bad, is to make the default value for trusted keys. Why is this a dictionary? Like, oh, maybe it's really a dictionary. How do I think this is how I specify an empty dictionary. Let's see. Yeah, if I didn't build this but just ran PyTest, it would be a bit faster, so maybe I should do that instead. Okay, we have one failing thing so far. Okay, we have one test failing. Which one is it? Test sign resolved hook. I don't like this test. But this was passing yesterday, I think. Test sign resolved hook. We will actually have to verify that. So it depends on this. And we might have not correctly updated that. Otherwise, we didn't change anything. The exit code is 2. All right, so I was misreading this. So, and we did change the exit code of things. There's an exception that happens. Or like, let's recall the Exit codes for verification. What is 2? I don't see that in here. But this is a test for signing, I think. Right? No. Yeah, CLI sign. So on the CLI, when do we... I don't see an exit code 2 here at all. Let's just do the quick and dirty thing, just in case it catches something. No, we don't find that. Okay, so we're just gonna invoke PyTest directly. Oh, we didn't run that in the... We didn't run it in the sandbox, the tests. We have tests passing, which is great. And we're not finding valid output hash mappings because... Why is this printed? Let's see. Yeah, let's stop this. Found so-and-so valid output hash mappings. Okay, we're not mocking this away, we're mocking this away. What, or let's... We're mocking something away. What do we mock away? First of all, we found more than one match here. Yeah, that's not it. This is it. Is this meant to be just called, or is it... Let's go through the tests. Because we're wondering why the verify signatures function is called, if that's correct or not. So here, what we're mocking away is signature fetch, fetch resolved trace signatures. And if we look, okay, this is what we're mocking away. So it's fine that verify signatures is still invoked. But why does it not find valid signatures? Because this is just strange output. Okay, maybe what we should do right now is verify if resolution, like even if the tests pass, we don't have good termination criteria for the tests yet, and maybe we should have added those as the first thing. But we didn't, and so we have to live with that, and we have to oh, thanks, Dawn, I didn't see your comment. About the path in the sandbox. So we should verify that, yeah, those tests are passing, but especially for the verification tests, do we get to the correct result? Because I think we do, and then this number doesn't make sense. So Bootstrap stage 1 standard environment Linux resolves to this. And what we're trying to do in that test is exactly that. Yeah, exactly that. And like I don't even, like I'm very convinced that this should be fine, but to be extra sure, let's look at the name in here. Yeah, this is fine, this resolves correctly. And here, like if we say, like just to show end to end what we get from that, we know that the hash of that thing we just resolved is supposed to be this. So for an individual signature, we can go from the input to the output, and like the signature scheme is about doing this for every link in the tree. And this path is the content addressed path, because right now what we do only works with content addressed derivations. So we might as well just use this as the hash, quote unquote, rather than this, because it contains a content hash. All right. So that works. I'm assuming that the large one also still works. Yeah, this is weird. We're gonna have to investigate. QAL. We find that in 2 different folders even. I'm wondering which ones are those. Okay, by name and by resolved input hash. All right. Yeah. And we are able to resolve the hello binary. This is the big achievement of yesterday, because it takes a lot of steps to get there. I actually want to, like, one of the things that I also want to record is like aggregate up how many steps we actually did in resolution. But we can kind of cobble that together by just grepping for, we changed how this is. So we changed the output format to be more sensible. So unfortunately we have to grep for something different. Let's grep for this, which is hilarious. Oh no. Now we have to do this magical dance of redirecting everything to standard output from standard error. 0 valid out. So this is all of the signatures that we fetch during resolution. So this should be the number of steps we're taking. $138. Oh yeah, but yesterday I was doing similar things and I came up with a number like 55. But 138 sounds about right in terms of how many signatures we actually have. I'm just not sure if we actually have signatures for fixed output derivations as well, which are just leaves in our dependency tree. So maybe we wouldn't count those. And maybe it's like 55 plus something to get to 138. So yeah, we would have to do a closer look maybe. But it's a bunch of things we have to do actually to verify the hello binary. We have to manage to get through the whole bootstrap. But yeah, this is still working. So then let's encode this success condition in the test. We want to end up with this as the output hash basically, but maybe it's good enough as a validation criterion to go by the input hash for now, because then we know, okay, resolution works. Test verify. So we get a list back. Yeah, maybe. I don't know, I just want to set a breakpoint here. Maybe we'll try to run this. It shouldn't fail, right? Because we fixed all of the things. So it will just take some time, and then it will end up here, and we will look at the output, and we will know how to formulate those criteria. Okay, we find two things. The unresolved derivation ends up here. That's a bug. Cool. So we found a bug already. But if we take the 0th element of that list, that should be the resolved derivation. We should assert that the length of this list is 1, which it is right now isn't. And then we take the resolved derivation and what can we do with it? Let's see. Yeah, the input hash. We want to assert that the input hash equals, sorry, what? QAL8. Let's look that up again in the data by QAL8. What is this? Yeah, this is hello. Fine. Okay, so I just had the wrong thing in my clipboard. But in general, I don't believe in, like, if you have the debugger running and you have, oh, this is the reference value. No, let's just really check the data. This is the experimentally determined, like this is the one that we found ourselves in the file, and it luckily also matches this. Like, we verified that it's for the hello derivation, and this is supposed to be the hello derivation. So we verified that relationship manually. We're not just taking what it's giving us and trusting it. Good. I think this is kind of how that test should go. So let's get rid of this assert for now, because I care about this assert first. Why is this not? Are there nested lists in here? What terrible thing is this? Oh man, yeah, the return type for this is just messed up. We will have to fix this. But if we run the test now, we will see if our very compromised, if our test passes now, and then we can clean it up. Yeah, I mean, this works out good. So now let's get rid of this cursedness, because it should be something like this. Because we think what we will get back here is just one specific trustlessly resolved derivation. And I don't know why we get the unresolved one, like get a bunch of weird nested stuff. Still, I think we might want to go through here now, and I think a lot of those changes are good. Oh, I hate this kind of trailing white space. Invalid signature payload. This is in the verify signatures file. Good. We also don't need, if we look at the tests, we don't need this business. But and this test is going to fail now, but I think this is a state that we should record, because we have the functionality working and we made a bunch of improvements. Oh, we want to patch things. I can increase the font size here. We'll patch file 2 through 8, or patch update those files. Yeah, looks good. We added type information here. We haven't actually run this, but I think that's fine for now, because yeah, this is fine. If we break this, then we've broken it. It's a balance, right, between how fast and slow you want to go. These are the things we added to the config. I think it's a good idea to have this in here, because like I really like using recursion for certain things, but if you then if you passing around a lot of parameters is really annoying, and I wanted to avoid a lot of the object orientedness of Python, but I think something like a config object is just useful, and maybe we'll also use it for the file paths we have lying around everywhere, and maybe also take them out of the recursion as Serge suggested. But that, like doing that nicely, we should probably have a typed object for that. And yeah, I'm thinking about it. Yeah, all of this looks like sensible improvements. Yeah, I mean, we do actually validate this now. So the to-do shouldn't be there. But we can amend that. So I seldomly just use this tool on the command line, and we haven't been running validation, like verification in the VM tests. So I'm kind of assuming that this is broken a bit, which is why I don't take a lot of care about it right now. fine. Yeah, this is what I meant, like these parameters we can get rid of. Like this should also be in something like a config, but then also we might just, like Serge suggested to me, hey, don't write this in your recursive loop, just build up lists, and that makes sense. We also make it more testable that way. He also recommended a bunch of other stuff to make or recommended another thing in the laut channel, which is, and it's also related to this function and how it's a bit terrible, like because I'm using mocks to I'm using mocking as a mechanism to get rid of the side effects for testing, but we could also like pass those impure things in as parameters to the function. And to some degree, like, yeah, I agree that conceptually that's good. The issue that I have with it, and I'm still thinking about that, is this function we have that does the signature collection. By definition, what it does is very pure. And it's not like there's not a lot of logic here or a lot that could go wrong. Either you look in the right places and find the things, or you do something wrong and you don't. And so I don't know if there's a lot of value in making that testable in that way. So somehow I'd just like the mocks to work, but we will see. I understand his point and I agree with it on a conceptual level, definitely. It's just a matter of will I actually implement that in practice and when. Okay, so we changed that. That looks fine. Yeah. I think fine with those extra spaces. No, in fact, I'm not, but this is good. Yeah, we should do that for the other test as well. Let's do that now. Even if it makes it fail. It's already what we want to have in the test. And probably we can get rid of this memory tracking stuff. I used that. Oh, this is not in here anymore. Never mind. Let's get rid of this. I had a lot of issues running out of memory when I was totally ignoring some of the annoying parts of Python and not realizing that, like, or maybe if I go into this at all, I should go into it properly. So one thing that's a bit difficult in implementing this kind of program is you deal with this dependency tree in Nix, and if you want to do anything like walk through it or instantiate objects for every part of it, for every step in it, something like that, you have to really make sure that you don't have to do duplicate work for duplicate mentions of the same thing. So you should not, if you encounter the same dependency through a different path of getting there, you should totally reuse the same object. And equally, if you're recursing through the tree, if you get to the same node through different paths in that recursion, you should totally use some caching mechanism to avoid that, to avoid actually recursing into that. And again, and I have these cache annotations on the recursive functions for that, and that helps alleviate that issue. But since I have data structures in Python, which is that actually model the resolved derivations and so on, I had the issue of, well, those were data classes, and Python automatically generated methods that would represent them as strings, and creating this string representation was like a backdoor into that exact issue, where if I depend on something through two different paths, it would end up in the result string twice or something like that. And I never saw those strings, but like Python was getting really upset with me and taking a long time to do basically nothing. And yeah, I'm not sure if I actually eliminated all of all of these sorts of problems successfully, but in practice I can work well with the code base now as it is. So now we're looking for this guy, and again in the reference data by input hash we find it listed as this, which is I think what I had in the clipboard before. And anyways, if I'm wrong here, then the test is just gonna fail. So that's okay. Okay, we got that. Now we'll just go through this again. Yeah, we removed that to do, removed those spaces, added the assertions that we want in here, and removed all of this stuff. So like the consequence now is I think that the tests don't totally pass because of what we just added, but it is good still. What do we call this? Clean? No. Like we're cleaning things up a bit, but we're kind of work towards like we did dependency resolution yesterday, which is technically the most difficult part of this, I think. It's the technical core of what we're trying to do, but now we're trying to like create a add all of the missing pieces, so we can really say, oh yeah, we're doing verification. So how do we? Yeah, I think this is a good summary. We're cleaning things up a bit. And we're working towards, like, we're implementing more pieces of verification. Yeah, we can push this. Unfortunately, CI will fail because we have an issue there. And this will also fail now because of what we just added. But it gives us the opportunity to clean up. Yeah, we have two things in here. What the hell? I think we should look at the signature collection function. See if we can identify where we're going wrong there. Because it should be a flat list that we get back. Here we're just returning the trustlessly. So in case the return type of this is a list. In case we are dealing with a fixed output derivation, we just create a derivation object for that, and we just have a list with one element. So this isn't the problem. So we have to look at the other return and what factors into it. The other return is for the case where we're actually dealing with a resolved content address derivation, or like we're dealing with the content address derivation and we're resolving it and returning all of the, like, I'm calling it plausible resolutions here because I didn't do the signature verification yet, but we're also adding that, right? So this is a list. It should be a list of trustlessly resolved derivations. And we're adding a resolved derivation here, which is something we're creating on the line above. And how else do we modify this data structure? Plausible resolutions. This is a list of trustlessly resolved derivations. And we're adding things to the list. Again, from this, I can't really tell what the issue would be, because this append looks harmless. And this is what will eventually... Oh, okay. Maybe the issue is not in this function, but one level above. Where this is invoked. So we get this result back. What do we do with it? Yeah, we're doing wrong things. Actually, what we want to do is, like, at some point it made sense to want to return the outcome of every step from this function. But I think since we're putting this in the data log file, that's not required anymore. And the reason why we had unresolved derivations in there is because we're returning the actual result, which it has the format that we expect, but we're also returning this cache that has the resolution for everything, or all of the possible resolutions for everything. And I think we don't need to return this here. Like, this is one of the rare cases where I'll just comment this. We'll just comment this out and do the other thing, because I don't want to throw this away right away. I also don't want to fish it out from history again in case I need it. We will just keep this around in a comment, and if we come back to it and realize it does not bring us joy, then we will throw it out. But we will not do that now. And then we also have to fix this return type. All right, so this should be sensible. I think this looks good. Yeah, good. So that wasn't hard. And I think it's sufficient to just call this change fix return type. Just taking everything that's in here. Simplify. Good. So we actually are correctly testing this now. We can even validate that. Because I'm like, sometimes I'm a bit paranoid with these things. Oops. This should fail now, right? Yes. Good. Good, good. What else? So now we have other things we could attack. Let's think about that for a bit. Since this is the last stream, I wanted to, like the last stream for the development week, I wanted to really get far and make it a longer stream. Is this ambiguous still? Or was which one of those was actually ambiguous? We should just have two different tests for those. Should I do that now? Yes, this is ambiguous. So I don't know precisely how the bootstrap of Nix packages works in detail, but I'm assuming that, let's go to this test file again while I talk about the tests. We can actually delete this folder. I'm assuming that somewhere in the bootstrap we generate like two different versions of a bunch of derivations that like serve slightly different functions as part of the bootstrap, and they are just not named uniquely. And so we have a bunch of things that are called the same but are not actually the same. And I haven't like investigated the differences closely, but those are really resolved derivations. It's not like one is the unresolved one and one is the resolved one. They are both resolved. Yeah, I think it's fine that this is ambiguous. I think we can update the comment to reflect this. Yeah. Funnily enough, I don't think we can verify the other one. Or, we'll have to check, are there also two versions of the unresolved derivation? Let's see. I put all of that into the data folder here, and we have to go input derivations. One, like we have one P3 whatever, and we have one BS something. Okay, there's just two versions of this. Also two unresolved ones. So it's not that resolution is ambiguous and we somehow resolve two things, one thing to two different things during the bootstrap and build both of them. We actually have two different unresolved inputs. Okay. Should we create another test? Like, I don't know. Yeah. Maybe. But I don't like the duplication that causes. And we will do that we will deal with that later on. Actually, we wanted to think, okay, how do we move forward now, right? There's this weirdness we can investigate if we run pytest.s. Why does it say found 0 valid hash mappings? Maybe we'll look into that. I mean, it does say it for the large one probably as well, but in general, if you can avoid dealing with large dependency trees. No, I can't finish that sentence. My heart wouldn't take it. Ah, probably the list of keys is empty, right? I'm assuming that's it. Trusted keys is empty, yeah. And signatures is not. Okay, so we have to now create the mock for the trusted keys. And that will enable us to test that functionality of key verification. Because right now we just know that we can go through the code path without things blowing up. Good. Well, that was on the easy side to find out. So we're starting to like add a bunch of mocks. Maybe we should group them together. Because this pre-image index one should probably also apply here. And the config debug one. If we build with debug config, should we just maybe we like, what else is it? Like, is there other tests in here? No. This is just verification tests. I don't know, like maybe we should just have one big mock that does everything. Yeah. I mean, we want things to still work when this stuff is disabled, but this is something that I think we're going to test on the command line anyways. At least we can still always figure out a better strategy for grouping things. But this is the point in time where I don't want to introduce a third thing. And instead want to group these three things together. Okay, config, trusted keys. And we're gonna take this. We're doing it like this. Gonna be a list with one item, which is one key, and then we're setting this here. And now this is probably gonna blow up in our face. Yeah. Mock config pre-image not found. Yeah, that makes sense. Pre-image index is anyways not a good name. Speaking of good names, this is another thing I wanted to do. Git move tests. We already renamed a bunch of stuff yesterday, but there's more things we can rename. Hello AI. What did I want to rename? Input DRVs. I wanted to call this. What else is there? It's input DRVs and traces. Because I was thinking of calling this trace lookup. DRV lookup. So then we have DRV examples and we have DRV lookup, and then you know, okay, one of them is just a set of examples and the other one is really like I can index into it and I can do a similar thing with the traces, where we can say traces and then lookup by name, lookup by resolved, and then signatures. And like the structure of the things that have lookup in the name will be similar. Yeah, let's do that. Lookup by name. It's a bit unfortunate that the file names are getting longer, but I think for clarity it's important. For clarity it's important because it's difficult for me to correctly navigate this while I'm thinking about other things. I can't imagine it's possible for other people to understand if I, as the author, have a hard time. Yes. So this is gonna break a bunch of stuff, but I think all of those paths should be actually pulled out here already. We will see. Maybe one of them is traces, lookup, and the other one that could have some of them is here. Example DRVs doesn't change. Let's just try. Okay. What file do we not find? This seems like annoying. Missing one required positional argument input hash. I don't get this. The key error is an artifact of the caching. Yeah, let's look for element strings by name. unresolved. This is fine. There should really be better error messages for this. Could it actually be that makes a difference that there's no? Okay, let's stash this and see if the tests succeed. Yeah. Okay, so didn't build unresolved tree. Man, I don't want to see this report. Actually, I want to see the brief version. Yeah, test verify and build unresolved tree. All of that stuff fails. But before I started the renaming, did things actually work? Because now I'm in the unfortunate situation where I don't know, is this now because of the rename? Or is it because of the other changes that I made, because I don't recall? But anyways, those boil down pretty much to setting this trusted keys thing, and that triggers a bunch of additional logic, right? So okay. Do we have to maybe even add this config here? I mean, I don't think so. These are succeeding now. Build unresolved tree. Okay, let's do another experiment where we actually add this monkey patching back in. Because if this makes one of those tests fail now, yeah, okay, that makes tests fail. But then I'd say, fine, okay, yeah, this just triggers that code. This just triggers that loop that we previously skipped to actually do things. So it makes sense that we're introducing failures there. And now we can just focus on what's happening on that other set of tests. Yeah, and here we just have something called input DRVs, which is again obvious. DRV lookup. And I was looking in. There's this memory code thing. Should I kill this? Don't know. For sure these things should be on top of it, because otherwise I apparently don't see them. Yeah, let's kill it. Things are working again. Good. So this is mostly now renaming a lot of stuff. What else? It's mostly renaming, I think. And start implementing. Yeah, we can commit that. Oh God, we don't want to, or maybe it's not so bad. Stage, yeah, that's fine, 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 fine. Should, like, we could cleanly separate this, and yeah, let's do that. Oh no, we're past that point already. Start. Because at some point this was working. So let's say we're fixing it. Okay. We don't have anything here now. What do we do? I'm having a look at the time. Thinking maybe we should take a break at some point. Not just work through all the time, yeah. Otherwise it's gonna be too much, probably. So where I think we want to continue is if we look at this here, we can like comment that back in, and then the tests will start failing and we will have to fix signature validation, and then eventually that will lead to us actually, that should lead to us actually verifying those signatures, and then we can start passing that through as a command line argument, and then we get, that takes us in the direction of fixing the VM tests, because if we have a command line argument where we can pass keys, we can, we could actually also just start running the VM tests without this, right? It's just a matter of are the VM tests of the opinion that we can resolve the thing? Yeah, okay, so there's different paths we can go towards. We can look at the VM tests and trying to turn the verification parts of them on again. We'll do that with like a really small set of derivations. We will not involve the low derivation, and that way it's not as bad in terms of iteration times. So I think we can still make progress here. So let's just take a 15-minute break and then we'll continue. And today I just want to go as long as I like to. Have it be a bit of a longer stream and then say, okay, this what we end up with is what we managed to do in this one development stream week. All right, so I'll see you after the break. All right, we're back. Hello again. Back after the break. Hopefully we have some fresh eyes now. I mean, it's not like we were stuck, right? But we wanna... what we're working on is, we managed to do dependency resolution yesterday for the hello binary, and now we want to make sure that we have as much of the user experience that we would want for verification as possible. So we're fixing the technically easier but still important parts that have to do with this, like just signature validation and so on. So right now there's a loop that we're not running through in the code actually, which goes through all of the trusted keys. You can find this. Goes through all of the trusted keys and tries to verify the signatures. And right now, as soon as we configure this to be used by adding this mock, the tests will fail. And we can fix that. Verify resolve trace signature missing one required positional argument. Input hash. Let's see. This is, I think, is it in, what was it? Verify resolved trace signature. Okay, it's in the verify signatures file, but the usage is in the fetch signatures file, because this is probably the usage that we're having a problem with, right? Because this should be irrelevant and not called at all. There's 3 arguments here: the keys, the signatures, and the input hash. Here we have the key and the signature. Like, we also modified this function so it only deals with one signature at a time. Because we have multiple keys, multiple signatures, and so on, and like the nesting is arbitrary somehow, and I don't know what to prioritize there yet. So let's not for now. Okay, we need the input hash for sure. Probably this needs to just be passed in here, right? Maybe even as the first parameter. Yeah. And then we say, so we do this so we can pass it in here. And now this should be fine. We have a squiggly line here because the trusted keys thing could be none. Trusted key object cannot be converted to bytes. All right, so let's look at that other invocation again, because it's not used, but at least we have like a format that we're using. key bytes. Self.keybytes. So this is a key. And we're initializing this with the key bytes already. Like this trust model code is basically, we're gonna throw that away. We're doing that in data log, the actual verification of the tree. The only thing that we do in Python is we verify individual signatures and maybe additional criteria per signature. But then if we consider it valid, we create a line in the input data for a data log program, and the data log program will build up the tree in terms of like the dependency tree and make it so that we verify each link in it. And it will also build up like the trust model, which is the keys and set of keys that could be arbitrarily nested that we trust. And the way you compose those will be like a threshold function where you might trust 1 out of 7 keys, meaning if any of those keys has a valid signature for this, then I trust the link. Or you could trust 6 out of 7 keys, meaning all of those 7 keys, 6 have to agree about the mapping, and then I trust the thing. But we're not implementing that yet. Also not this week. Like, very certainly. Okay, public key bytes raw. From public keys key bytes. This parse Nix public key. What function do we use in order to fill that test, right? Let's see. Read public key. What does read public key do? It returns a trusted key. Okay, and the trusted key is this trust model object thing, I think. So this just has key bytes. We just, like, I don't like this class, but we can just deal with the key bytes. So we'll just take the key and take the key bytes of it. Okay, we don't know the type because it might be none, but theoretically, like, this should work out. I think if this works, we're doing signature verification. Oh no, it takes a bit longer. Cool. We're doing signature verification. Why did this go so smoothly? Now we have to kind of try to break it. How do we, like, because I want to have a negative test for this somehow. Maybe we should even have one encoded. Like, we don't have to have a negative test on the tree level, but at least on the individual signature level we should. And maybe on the tree level it would be good as well, actually. I'm thinking. let's do this thinking in a structured way by looking at the data. So this is the data that we look up if we do the signature verification. This in pre-image thing is just really the JSON representation of the derivation, because this is what we're hashing right now. But the important parts are the input and the output. And this is also, it's kind of oh no, it's not too late. We can, if we just, what would happen if we, like this is the payload from the signature. Okay, I have confused myself now. Because I'm not sure in those unit tests, do we just have the payload of the signature, or do we have the actual? Let's see. What we're mocking away is the fetch part. Fetch, resolve, trace signatures. We're mocking this away, but we're still then verifying it. So we really get the actual signatures, and we look those up in, we can also verify that. Mock signature fetch. We get the data from lookup by resolved input hash, builder A, because this is, so we have an input hash. But if we're looking this up in here, we're like, how is, like, this is not signed anymore. What's signed is, for example, like, we have a folder in here. It's called signatures. Traces, signatures. And these have like the base64 encoded header, payload, and actual signature. So this is a JSON web signature. And in this file, we just have the payload. So something's not right. Maybe I should set a breakpoint here and just see for myself what data we get in. Yeah, this is the payload. So if we now step into this function, the all signatures thing is just a list with that one payload. And the input hash is the the constraint on it that we have to verify, because we're saying we think this is a valid signature for this, and that verification should fail if the input hash is something different. And what the output is something that we find out by looking at the payload in the end. So we have a signature data list because we're looking at different keys, right? And we have one key that we look at, and we have one signature that we look at. And then we have the key bytes, we have the signature, and we have the input hash. And if we step into that, what's happening? We instantiate the key. We have a set of list of output hashes. We verify the payload by passing in the signature. And then, like, probably this is just an empty thing. Let's say step into. Okay, now we are doing the payload verification. Get unverified header. This is stupid because this thing doesn't complain at all that we're passing the payload in. Do we get a thumbprint? Or am I like imagining things? What is the thumbprint? BCDA. Is this just like the stupid representation of that thing? What is going wrong? Yeah, this is not a string. It's a thing that has a thumbprint, so this is typed. What is the actual type of this? Okay, here we don't have it yet. Fetch, resolve, trace signatures. We get something back from there. A list of dictionary. We're loading the content. Getting the signatures field. Okay. And then we're returning this. Input hash. Yeah, the dictionary I'm seeing here is not the full signature, it's just the payload. And that matches with... Oh, I confused myself. Haha. We can't look at this because this is what we get from... This is when we actually go to S3. We're not going to S3, we're mocking this away. So that's why we are just getting the payload. But then why does this thing have a thumbprint? Okay, we're getting the thumbprint of the key. And now we're getting the header. Okay. I was just... Yeah, and this is failing. Okay. We don't have a payload. Great. So there's no input hash. Valid output hash is empty. So we're finding nothing. Good. Good, good, good. Let's step out of this actually. Yeah, there's no valid signature data. Do we append anything here? No. Oh, it's length 1 now, because we... Okay, because this can be... This is a dictionary. If... There should be a big fat else here, for sure. I don't know about the inner if even, but else return none. Where do we get those? Like, what is the issue with... Because if we go in here, we're appending something. This is a joke. There's no loop in here, but there used to be, right? So either we're returning a dictionary or we're returning none, I think. Because this was a list, and then of course it would have an empty element. So now we just do it like this, or we could make it an optional actually. That's, I think, more idiomatic. And then still the thing we're returning in the else case is none. And only here we should actually this is instance check. That seems like idiotic, because I don't know. Like this is not supposed to be like a productive cryptography implementation thing. This is more supposed to be a we're proving the concept thing, right? But for sure that could change quickly. Yeah, now we don't have... Oh man, my TV is turning off. Don't want that. Like my monitor, I mean. Yeah, the simplest thing conceptually is to just also return none here. And like the reason why I did that was because I had the impression that if we invoke append, we get a list with an empty element in it. That's annoying. This I think makes sense. Cool. But where does this leave us? This leaves us with, well, our tests don't actually include the signatures in the test data yet. Now we could add the actual signature to this lookup by whatever file, or we could actually just index into this signatures folder directly. And then if we have a mismatch, we just get a file not found. But we also kind of have to, I mean, that's very close to the logic that we have on the S3 side. So these are the files that come from S3. So maybe if we mock in a slightly different location and split up that S3 method a bit, we can just split out the S3 specific parts a bit. We can just have the mock access those files. Maybe that's nice. And then what we can do is we can just change some bits in, like then we can actually verify the signature. Let's see what happens now actually. Okay, so we should make this test fail, because as we saw, we don't get any valid signatures, so this should be failing. And we shouldn't actually be able to go through the validation. Sorry. All right. Let me think. Where are we in the debugger? In here. Oh yeah, because we're still doing the no-op thing here. Valid signature data list. This is what we should return. And this is not like a bug that's been long-standing. We are working on this since last stream, and now the verification fails. But okay, why does it find a valid output hash mapping? And why does it explode with this build unresolved tree? Rec. Like this should just remain an empty list, right? Let's just check what's going on. Okay, there's length 1. What do we have in here? We have like an empty list and an empty list, I think. And I think this is something we actually wanted to address with our changes. So maybe if we just restart the test. Like this is a list with a list in it. And we kind of, yeah, I think maybe we fixed this. Let's add a breakpoint here. Okay, we have the none that we add to the list. So what we have to do is if valid signature data, then we append it. And that way we shouldn't find any valid signature data. Let's go to the log actually. I don't see it right now, but it's, yeah, it's an empty list. Let's continue here. Fetch pre-image from index, and this crashes now. So we didn't find a signature now, because we didn't find a valid one. These are two different cases. That's a bit unfortunate. Because like this is some logic that I added to be able to nicely diff to have a nice diff for what the hash, what the input to the hash on the builder side was and what the input to the hash on the verification side was. And that is helpful to debug certain issues. But of course now, like we run into that every time we end up with a hash that we don't find any valid mapping for, and then we try to create a diff between an invalid one and between the one we ended up with on the verification side and the one we think that we ended up with on the signing side. And I need to think about what this means if what it means if we now do signature verification and the signature like is not valid, but we still found something. We might have to still feed it into this comparison. if not signatures. And like, so if we don't find a valid signature, we try to do this business. Yeah, I think I am a bit too spent to actually deal with this right now. So I'm thinking, how can I pull myself out of those details? We've been streaming for 4 hours. With some breaks, but still. I'm not the person with like the longest concentration span. And I wanted to do the longest stream, but I think like having a marathon stream with programming for me is not that realistic, it looks like, at least for now. Yeah, I think we're working towards having a better UX, like doing the actual signature verification, and putting that into doing the actual signature verification, outputting a proper result. But as of now, we're in the process of working on those things. And as of now, we haven't produced something that we can actually give to users. Even if the signature verification didn't happen, I would be fine. I'm not sure if I would be fine with that. And users, I mean, people who want to just try the thing out, right? People who want to run the code. I don't think we're ready for that. And the most significant issue there is that we have this, that we do the hashes of the derivations based on a JSON representation, and the JSON representation is not stable between Nix versions, and also not between Nix and Lix and so on. And we already, like, this is something that was fine to start out with and play with this stuff, but we might have to find a way to fix that by switching to the A-term format or do something else that's clever. Or normalizing certain things. Yeah. So where does this leave us? I think I really enjoyed this experience of streaming for this week. I had fun with the schedule, trying to keep with the schedule, and sitting down and actually doing this focused work in a way where I communicate what I'm doing. That was fun. The interaction at the end of the week was also fun. And I think it shows, hey, we're working on this. We are taking this seriously ourselves. I think it's good for people to be able to see that, right? And see us also make a bit of progress. And that's good. I don't know if I'm going to continue streaming or to continue to do programming streams. I think I want to like sit with this experience for a bit, think about it. For sure, I'd love, if you're watching this, if you would engage with the project. Talk to me, let me know you watched this. Let me know what you thought. And I will write down some kind of conclusion, I think, and post it on discourse. But it might take some time because I really want to collect my thoughts. And that's the best I could pull myself out of the detailed issues for now, as I'm kind of exiting this stream. So yeah, thank you everybody. As I said, this has been a lot of fun. And hopefully we can really like move things in the Nix ecosystem, do interesting stuff. I wanna really get stuff working and get stuff deployed. Because I feel like there's things we can do here that are really sensible, especially in terms of like, first of all, really raising the bar on security and making real improvements that are visible to people, creating like a basis, a common basis for people to work on top of and like evolve the ecosystem over time. And also I see a lot of potential of using something like this as a tool to get content address derivations into production. Because we can have like a signature format that represents inputs and outputs in the same way for both input address derivations and content address derivations. So we can have like input address builders generate data that can be verified against content addressed criteria, quote unquote. And that is a migration path. It's a nicer migration path than fetching paths and then converting them locally on the client. And it's something that we can also like, it's a migration path, but it doesn't it doesn't create everlasting headache, because in the builder section of the signatures we can say, hey, this was created by a builder for a content for an input address derivation. So in 5 years, long after the migration, usually this would be turned off. And maybe also like the whole input addressed code path would be turned off if you don't need that. And I'm particularly excited about that for the ecosystem. So talk to me about this stuff. Let's work on this. Let's make things happen in 2025. All right. Thank you. Bye.